All right, hi folks. I'm recording a video for section 3.1. 3.1 has to do with linear functions. Now in chapter 3, we're going to be covering both linear and quadratic functions, but right now this section is focused on linear functions. So let's take a look at this example here. It's asking about the average rate of change of a function from the point 3 to 6. All right, well, for this question, we really want to understand, what does average rate of change really mean? What are we being asked to find here? Well, when you see rate of change, it really means slope. So whenever you think about slope, it can also be expressed as a rate of change. Now, let me remind you that slope, you might remember the slope formula. It's y2 minus y1 over x2 minus x1. Well, think about this as the change in y over the change in x. Well, that is a rate of change because I'm figuring out the change in the y's and the change in the x's, and by dividing, it's going to give me a rate of change. So really what I want to know here is, what is the slope of this function? I'm just going to draw a function here. Let's say this function does something like this. And here is x equal 3, let's say. Here is x equals 6, let's say. We're really trying to find the slope of the line joining these 2 points. Try to draw it in red here. So the slope of the line joining these 2 points. Well, for us to do that, we need to know what is the x and y value of these 2 points. Then we can plug into the slope formula. Well, I do know the x values. This first point, the x value is 3. I don't know the y value yet. For the second point, the x value is 6. I don't know the y value yet. But I can find the y value because I'm given the function. So if I want, instead of writing f of x, I can write this function as y equals 3x squared minus 3. You know, keep in mind this notation, f of x and y, they're really interchangeable. All right, well, let me go ahead and figure out the y values then. If I let x equal 3, then I want to figure out the y value. So y equals 3 times 3 squared minus 3. Well, 3 squared is 9. 9 times 3 is 27. So this is going to be 27 subtract 3, which is 24. Okay, so I know the y value here is 24. All right, let me do the same thing for the other point. For the other point, the x value is 6. So I'm going to let x equals 6, do the same thing. Y is 3 times 6 squared minus 3. 6 squared is 36. 36 times 3 is 108. So this is going to be 108 subtract 3, which is 105. So I now know this other y value, it's 105. All right, well, now I'm ready to calculate the average rate of change. I'm really just going to calculate the slope. So let me label these points. Let's say I'll call this x1, y1, and x2, y2. By the way, remember, it doesn't matter how you label these points. Let me make x1, y1 there, and x2, y2. Right, I could swap around the labeling. It wouldn't matter. I would get the same answer here. All right, so let's plug into the slope formula. y2 is 105. y1 is 24 over x sub 2 minus x sub 1. That's going to be 6 subtract 3. All right, now I can figure out the slope. 105 subtract 24 on top is 81. And 6 subtract 3 on the bottom is a 3. 81 divided by 3 is 27. So the answer to this question is 27. Okay, so in this answer box, of course, I would be entering the answer 27. All right, let's take a look at another example. All right, here's a kind of a conceptual question. It says, state whether the following is true or false. The function f of x equals 2 over 3 x plus 15 is increasing on the interval negative infinity to positive infinity. Well, let me sketch a quick graph here. I don't have to be too precise. I just want to know if the graph is increasing or decreasing. And remember, if a graph is heading uphill, by the way, I know this is going to be a straight line. If a graph is heading uphill, this means the function is increasing. But if the graph is going downhill, this would mean decreasing. So I really just need to get a general idea of the shape of this graph. Well, I'm seeing the y-intercept is 15. Remember, I can use the equation of the line that we've already talked about, y equals mx plus b. So our y-intercept is up here somewhere, 15. I'll put a dot on the y-axis. I know the graph has to go through that point. And I'm also seeing the slope as a positive number. The slope here is 2 over 3. But if that slope is positive, it means the line is heading uphill. Right, so once I see a positive slope, I know this is an increasing function. So the answer to this one is true. This graph is increasing on the interval negative infinity to positive infinity. If this slope was negative, then the graph would be decreasing on the interval. Okay, let's go to another example here. It says the slope of a non-vertical line is the average rate of change. Well, from the example we did a few minutes ago, yeah, that's true. Right? You could think of average rate of change as a slope. So really, slope and average rate of change really mean the same thing. So the answer here is true. Do another example. Let's take a look at this one. It says a car has 12,500 miles on its odometer to begin with. Then you drive the car 40 miles per day on average. How many miles will be on this car after you've driven it for X days? All right, let me do a quick example here just to help me out. Let's say I was driving this car for 10 days. So X equals 10. And I want to know the number of miles. So N is the number of miles driven. And then I also want to know what's the total number of miles on the car. Remember, this is really asking us for the total number of miles. So let me write here, total miles on the car. Well, I know that I'm starting out with 12,500 to begin with. I can kind of think of that as the mileage on day one when I got the car. But I'm going to be adding miles. Every day, I'm going to add 40 miles per day. And I'm going to be driving for, let's say, 10 days. So in my example, it would be 40 times 10 plus 12,500. This is the starting mileage on the car. And because I'm going to drive the car for 10 days, and each day I'm going to be driving 40 miles, this would be 400 plus 12,500. This would be 12,900 miles in total. All right, but they're asking me to come up with a general expression for this. Well, you could probably see from this equation we just worked out, of course, I just picked X to be 10, but I'm going to replace the 10 and put an X here, just to make it a more generalized function. Right, so every day that I drive is X. For that, I'm going to be adding 40 miles per day, and that's going to be on top of the 12,500 that I started with, so it makes sense this should be the function that I'm after. And the only answer that seems to make sense for this is answer A. All of the other answers don't seem to match up to this analysis we just worked through. All right, hope this is helpful as you're getting started in this section 3.1 homework.